Okay, we're here going through exit slip 213, and our I can statement dealt with using ratio rate tables to help us solve ratio problems, real life problems. So here's an example of Isadora's mom making a special thank you card to give to her friends. And she uses the same number of heart stickers on each of her cards. And last week she made 6 cards and she used 24 heart stickers. So we're going to make a ratio rate table here to answer the questions. All right, so we're going to know, and we look at the ratio here before we get started, is that she did 6 cards and she used 24 stickers. So we're comparing cards to stickers. 6 cards, 24 stickers. So we're going to look at this different ways using this ratio rate table. So we know that we divide it up and make a few boxes on top and bottom there, and I'm going to label here so we're organized. We got cards here, and let's do the heart stickers. I'll just write stickers here on the bottom. So we know right now for every 6 cards there are 24 stickers. That's our rate there. Okay, so we're trying to figure out some questions dealing with this, but before we get started, the first question we'll talk about it. We've talked a lot about trying to get things to unit rate. They're easier to understand if you get one of them to a 1. And so in this case, I'm going to go, what would 1 card be then? And how many stickers on every 1 card makes it easier to understand the big picture. So I know if I divide 6 by 6, so if I divide this by 6 here, that gets me down to 1 card. So I must divide the bottom by 6. So 24 divided by 6 is 4. All right, so I know for every 1 card, I use 4 stickers. And that's a little bit easier to understand, so we put them in that unit rate. All right, so we're going to use that to help us here. So question A, how many stickers does Isadora's mom use for 1 card? And we've already answered that by getting it in the unit rate, so that would be 4 stickers for every 1 card. There's that unit rate. Okay, now we don't know what else we're going to fill into here. We'll see. We could make infinite boxes because these ratios could keep going forever in different forms. But let's see what they ask us to find here, and then we'll talk about it a little bit more. B says, how many cards can she make using 40 stickers? So I'm going to go down to this box and put, okay, we want to get to 40 stickers. And so what I'm missing here is how many cards. I'm missing the top. So how do I go about finding how many cards would that be? Well, if I look at the relationships here, the last time here when I went from here to here, I divided by 6 to get it down to this rate. But remember, we can multiply also to get things places. So I see a pattern here that if I go 4 stickers and I want to get it to 40, my brain sees that I multiplied by 10. Okay, or somebody, you could think 40 divided by 4. And that would get me 10. That tells me this is 10 times bigger. So if my brain sees that that's 10 times bigger, I know I take it times 10. I just need to take the top times 10 too. So 1 times 10 is 10. So I know 10 cards would require 40 stickers. Now I went from this way to this way. Remember, we can also compare the top to the bottom. So for example, from 6 to 24, do you see that if I take this times 4, it gets me to that? If I take the cards times 4, I get to 4 stickers. If I take 10 times 4, I get 40. So I could have just taken this 40. I know when I go from top to the bottom, I'm multiplying by 4. But if they give me the bottom, wouldn't I divide by 4? So I could think 24 divided by 4 is 6. 4 divided by 4 is 1. So 40 divided by 4 is 10. So I could look at it that way too. Remember, you can compare from cards to cards multiplicatively or divisionally, or you can go from stickers to cards. And as long as you keep that same rate multiplicatively or divisionally, it's going to work out. Question B, how many cards can she make using 40 stickers? Just did that, so that'd be 10 cards. And C, how many stickers does she use for 100 cards? So this time they're giving me cards, so I'm going to get that to 100. And I know I could look from here to here, and I see that it's 10 times bigger, so I could take this times 10. Or I know that I could go times 4 from here to here, like we just did, so I could take 100 times 4, and that would give me 400 in this case. And again, 100 cards with 4 stickers on each, that's 400 stickers. 400. And you just keep following that same pattern. So on D, how many cards can she make with 32 stickers? So now we've only got 32 stickers, not a big deal. Again, I can look at this. I'm going to erase a little of this now in a lot of different ways. I'm going to look at it a little different way here. I can compare all kinds of things. I don't just have to look at the column right next to it. Like for example, I see here 4 in this unit rate, 1 to 4. If I take 4 to get it to 32, I can see that if I know my facts here, 4 times 8 is 32. So I would do this rate 8 times to get to 32, so I must take the cards times 8, and I can figure that gets up to 8 cards. Okay. Another way we talked about doing it is, again, you could just divide by 4 from bottom to top, because there's always 4 times less cards than stickers. So 32 divided by 4 is also 8. So again, so many different ways you can figure this out when you see relationships between numbers. So this would be 8 cards. And then the last one, how many stickers does she need to make 51 cards? Better get this in here, add one more on. So this time I want cards, 51 cards. And I know every card has 4, so I'm just going to take 51 times 4. And use that, and I get 204 stickers I would need to make 51 cards. So again, hopefully you looked at lots of different ways and seeing the relationships from card to stickers or cards to cards with any of these in here. And usually you can find something that works pretty easily to get this to work out.